Hello and welcome to the Forest stage here at ETH Barcelona. I wanted to introduce to you Arnau Cube from Aragon Research. Okay, give him a hand.
Thank you very much. So hi, I'm from the Aragon Research team and also Bogdani. And today I'm here to talk to you about a research project that we've been working on for these past 4 months, more or less, which builds on other previous stuff that we've been researching. And the main idea is that we are building this protocol or scheme, which we call OVOTE. And the idea is that it's off-chain voting with on-chain trustless execution. And yeah, so, well, we will go through these things that you see also on the top. So the main motivation of this project is that currently in Ethereum, as everybody knows now, the gas costs are very high. So it's hard for people to interact with DAOs and so on. So we have these systems where people delegate votes, or people vote in a polling system, and then others like vote on chain and so on. So for example, we have this direct on-chain voting, which is like this. I mean, people is spending tons of gas just to express their voices. Then, the idea is that this triggers the DAO funds movement. But also we have these other schemes where like people vote on an off-chain poll, which is non-binding. And then we obtain this result, but this is not directly binded to the Ethereum smart contract. So then we need like this small subset of users, which are like the multi-sig owners of that DAO, who at the end, they encode in a multi-sig the result of that off-chain polling, and they execute this on-chain through a Ethereum transaction. As you can imagine, these people can screw it into any moment, and they can censor if there is something that the community wants, but it's not aligned with their incentives. So that's why we are building this OVOTE project. So the main idea is that OVOTE is a layer 2 design for voting using validity-proofs, also known as ZK rollup, or ZK snark rollups. The main idea is what I was saying, that votes are aggregated off-chain and then proved on-chain through a ZK snark proof. What we achieve with this is that we can aggregate thousands of votes and signatures and census proofs from users into a single Ethereum transaction. So as you can imagine, this reduces a lot like the gas costs. So a bit of context here, like we started this project like 4 months ago, but we are building on research that we've been doing for the more than 1 year now in Bogdani. And we aim that this can be like a contribution to the Aragon ecosystem. Also, take in mind that this is a research project with a very specific scope, with the aim to be like a first practical step towards this future of ZK technology for voting and DAOs. But we cropped a lot the scope in order to be able to build something in a few months. But we plan to keep iterating that and adding privacy and other stuff. So how it works? The main idea is that, so we have on the left, there is this triangle. This represents the census tree. Basically, you can understand this as, so you have the list of public keys and weights related to each public key. And then this is what will build the census in the shape of a Merkle tree, what we call census tree. This is happening off-chain. Then when you create a new voting process for your DAO, you send the census root to the OVOTE smart contract. Then what happens here is you create this process, so people can start sending their votes plus the signature plus the census proof to the OVOTE node. And then this OVOTE node is the one who will aggregate all those votes and generate a valid ZK snark proof that, as we will see later, this proves that everything is computed correctly and the result, the climate result is correct. Then this is sent to the smart contract on Ethereum. And just with this single transaction containing the ZK proof, the smart contract can verify this. And if everything is fine, this means that all the votes that are computed for this result are the correct ones for valid users. So this can trigger execution on chain, like, and for example, moving the DAO funds or whatever. Then, so how this census works? we are using the same census that we've been using in the past in Bogdoni, and we are using like the same cryptographic primitives that we had in IDEN 3 and also in Hermes. So this Merkle tree is a sparse binary Merkle tree, where basically the idea is that we place on the leaves like the public key and the weight of each eligible voter. So then we can prove through the Merkle proof that a certain user belongs to the census. So how the flow works more or less. First of all, we have this census and process creation phase, where all the users, they generate new public and private keys, and they send the public key to the organizer. The organizer then will take all these keys and will build the census, as we have seen the Merkle tree, the census tree. And once everything is ready, the organizer can send an Ethereum transaction to the smart contract to create the new process, where the organizer specifies like the Merkle root, but also like a transaction hash and other stuff. The transaction hash is the hash of the transaction that this new process aims to execute if everything goes well. Then, once the process has been created, we enter to the votes casting phase. The idea here is that the voters, they first get the siblings. The siblings is like the Merkle proof. So also then they sign their vote option, and they send the vote plus the public key, the weight, and the census proof, and the signature to the OVOTE node. Then, after the OVOTE node gathers enough proofs and votes, the OVOTE node will generate the zk-SNARK proof, and then anyone, any user, can claim or retrieve these results plus the zk-SNARK proof, and then anyone can send this proof to the Ethereum smart contract, which will verify the correct computation of everything, and if everything is fine, we'll execute the on-chain configured transaction and moving funds or whatever. So here, like a little bit of like how this timeline looks. So this is like the line of the smart contract block timeline, let's say. Then, so at the first moment, we have that the organizer sends an Ethereum transaction containing this data, like the transaction hash, census root, census size, minimum of participation. This is the threshold of how many voters you need to have these results accepted. And also important here, like the results publishing start block and also results publishing window. This is, as you see, from the block N and to the block N plus W. This is the window of time where any OVOTE node can send a valid zk-SNARK proof claiming a specific result. So as soon as we are in the multisig mode, as soon as there is a valid proof that claims a result that has enough support, then this will be verified and trigger on-chain transaction. We have another mode that it's a bit more complex. Later you can check the full document that we have online, but the idea is that this is more like a referendum mode, where the idea is that you're not taking into account only that you have enough support. You want also to balance on how many users are voting no and how many users are voting yes, like a referendum. So for example, let's say that you have like 1,000 users, and you set a threshold of minimum participation of 100 users out of this 1,000. Then if there is like 100 users voting yes and 50 voting no, then it's a yes at the end, so this will trigger transactions. But in this case, if later appears as another ZK proof proving a result that is like, let's say, 100 positive votes, but then 300 negative votes, in the overall percentage, this will not pass. Sorry. It's a bit more complex to explain, sorry, but we have this well explained into the document that later I will link. But yeah, just take in mind that there are two modes, like the multisig mode and referendum mode, and so you can combine these into different kinds of voting processes. Then the results publication. The idea is that you can have multiple nodes. So if there is a node that is acting in a bad behavior, it's censoring votes or whatever, you could still, like, people could organize and vote through another node, which will gather and act honestly. So it's fine if there is one node that it's not acting honestly. Also, like, just to put some numbers, like the current SNARK proof verification, it takes like 262K of gas. And then the full results publication for the multisig mode, it takes like 400, but then the referendum mode, it takes like almost 1,000K. So 1 million. Then, OK, like the circuit. This is a bit tricky, but the main idea is that the circuit ensures the ZK proof, the circuit through the ZK proof ensures the correct result computation. So the idea here is that the circuit is ensuring and checking that each vote that is included on the proof and computed for the final result, each vote is signed by a valid public key, and this by a valid private key, and this private key its assigned public key is on the Merkle tree with a specific weight, and this is under the census root of the census tree. So the main idea is that we are ensuring through the circuit that everyone who is voting has the rights to vote, and also we are balancing with the weight of the public key, and also that everything is fine, that there are no votes repeated, and so on. In the documentation, it's more extended, so you can check it there also. Then, regarding properties, so this is the properties that we have for this current design iteration, which is the first one, but we aim to keep iterating this and doing newer designs and so on. But basically what we have now is this universal verifiability, also unforgivability, trustless, and binding execution. This is what we were aiming for, like to have this big scalability, but on the same time having this trustless system with binding execution that can trigger on-chain transactions. Then also, because of that, we have this off-chain gasless voting. So the idea is that we can aggregate thousands of votes, like let's say 10,000 votes in a single Ethereum transaction. So you can do numbers and see like how we are saving big numbers on gas costs and so on. So we have this scalability. And also because of the census is built off-chain, we have this chain agnostic census. So you could have your DAO with a specific census, and then you could use this census in Ethereum mainnet, or also in Polygon, or in any other chain. The main idea is that in order to verify the ZK snark proofs, we need to compute pairings on chain. So all the EVM like chains, they have this, and probably for some Cosmos networks also. Then, OK, properties that we are not covering here, but we aim to cover in the next months and years in future design iterations. So there is no voter privacy. This is very important. But so for this first iteration, we focus it into high scalability. But next thing is privacy. Also, no token-based voting. But also, it's not on the scope. But we understand that most of DAOs are based on this model. So it's something that we look into the future for that. Also, we are not currently, we cannot aggregate different results of different OVOTE nodes. This is something that we will also like to go for. Then what we are using, so basically we are using the Item 3 stack, like the Circom, Snark.js, Rapid Snark, and so on. So big thanks to Jordi Bailina for that. Also, we use a custom implementation of a compatible Merkle tree that we have, which is Arbo. Arbo is tree in Esperanto. So it's a Merkle tree that parallelizes by CPU. So it's like quite fast. But it's compatible with the Circom stack also. Then this is not just like a idea design project. It's also like we did an actual implementation of this. So we have the circuits, the smart contracts, also the OVOTE node, and then a small client lib to generate like the public keys and to sign and so on. So you can go and check all this code. Then, OK, direct use cases of this first iteration. So we have, as we saw, the multi-sig on-chain results, but also we have the off-chain referendum with on-chain results. So these two modalities. And then as an extra, because of the characteristic of this census that we are using, which is the same that we use in Bogdoni, in the blockchain, so this census allows us also to use it for on-chain anonymous voting. This is what we have already in the Bogdoni chain, but we could use also this for an Ethereum smart contract and so on, but it's expensive to verify each user proof. That's why, for the moment, we are focusing into the scalability, but then we aim in the future to iterate this and also have privacy. Then future research. OK, one thing that we have like as the next thing to look at is this OVOTE DAO. The main idea is that currently, as we saw, the census is built off-chain, and so this organizer needs to gather the public keys of the people. The idea here will be that people can deposit money to the smart contract, and while doing this, they are also sending the public key. So then the smart contract can be building live on-chain this census tree with the weights based on the amount of money deposited by the users of the DAO. So then at the end, what we have is like this live on-chain census tree based on the deposits of people on the DAO. So then these people can go and vote through the OVOTE design and decide what to do with this money that all of them are gathering together. This is something that we are looking for to build. We just need to build a smart contract, but the rest is like what we already have. Then as a future, more mid and long-term research, we have this proof recursion, ring signatures inside the SNARK circuit. Ring signatures is what Monero is using, and the idea is that we can have also anonymity inside the circuit. So we could have this high scalability, but on the same time having the privacy and so on. Also, Ethereum storage proofs and Ethereum signatures, this will allow us to prove inside the circuit like a census based on the current state of Ethereum. So you have some tokens in the Ethereum chain, so you could prove this directly without any intermediate step. Also, like we look forward into like research on results aggregation from different nodes, and also like other proving systems other than Graph 16, which is the current one that we're using, such as Splunk and Hello 2 and so on. So then that's all. As a main takeaway, we built this in these last months, and the idea is that this is a research project, but with the aim to be close to a final product that we can build and so on. The main idea is that you can think of this as a ZK rollup, but for voting. So we have this high scalability that ZK rollups has, thanks to the use of ZK snarks. And then the main idea is that the votes are aggregated off-chain and then proved on-chain through a single Ethereum transaction, which contains the snark proof. So we can scale up to thousands of users through a single Ethereum transaction, so reducing massively like the gas costs. So if you want to check more details, like this QR code, but also like this URL is the PDF, like the paper, the technical document that we have now on draft, which explains this and more stuff more in detail and more extended. So if you are interested, just check it out. And yeah, so I don't know if there is questions or comments. I mean, I see here that we have 3 minutes, but maybe I rushed it too much. So sorry. Mm-hmm. Good question. So the question is if we could add token-based voting using this weight of the Merkle trees. Absolutely. That's the main idea. But the thing is that currently with this fierce design, if somebody does this, everyone else needs to check that everything is well computed, like that the person who or the entity who is computing this Merkle tree with the weights based on the token holdings is acting well and is not adding fake users or fake token holders. But if everything is fine, then yes. We aim for these future iterations to have this in an automated way so that who builds the census tree is the smart contract itself. So then we don't need this human interaction in the middle that as at the end, is if there is a human interaction at some point, other people need to check it. But yeah. Mm-hmm.
You said the nodes can censor some of the votes. Can they censor? You said the nodes can censor some of the votes. Can they censor it by the address, or can they censor it by the vote, like no or yes?
They could do both, but the idea is that if this happens, like users can still, like you go to the front end, and then you could send your vote to multiple nodes. So if there is this bad actor node, you can still, like the rest of nodes, the first one who gathers enough support to trigger the transaction, will generate the proof, and anybody can send this proof on chain. So that will prevent this censorship attempt. Yeah, but good point.
So one question I have is, you mentioned the weight can be calculated, for example, based on the token. So is it going to be like something generic that, for example, we can have a smart contract that gives you a number, and at some point is the number of tokens, but in some more complicated cases, it could be, based on whatever we want to put in the smart contract. So it is still trustless, but it gives flexibility. Is that something that you're thinking, or just going to be tokens?
Yeah, that's a good point. Absolutely. The idea is that to have this as I think very flexible. So yes, this will fit very well. Also, like for the first, so we have this for this first iteration. Then we aim for a second iteration where we add this smart contract that builds the census on chain. But then from here, yeah, I mean, also one thing that somebody asked us was that if we could when we go for this privacy thing, so there is the privacy of users, but also the privacy of the DAO itself. Maybe you know what happened with the constitutional DAO, that they tried to buy in an auction through a DAO, like a piece of the constitution. So what happened there was that there was a lawyer firm who they knew how much money the DAO had to bet. So they could go a bit higher, and they knew that the DAO could not answer that. So if we can have a system where the DAO can also not show publicly how much money they have, this also is something to look at. So yeah, all these things, we aim to keep doing this kind of research and iterating, and yeah, and privacy is important, and also like this flexibility and composability, for sure. So, okay, so I see, I'm sorry, with the focus I don't see anything. I saw a hand, I think, but okay, no, false alarm. Thank you very much.